Hello friends, myself Pankaj Sethi. I am from Networkers Home Technical Team. Today we are discussing about IGP protocol. In IGP protocol we are discussing about redistribution. So let's see. Okay. So today we are going to do the redistribution between different IGP protocols. Here we are having 7 routers. Each router are connected like this. Router R1, R2, R3 is in OSPF area 0. R2, R3, R4, R5 and R6 is in EIGRP AS100, and R5, R6, R7 are in RIP. Okay. Now we have to first go to these routers and see if IPs are given. So if we check if IPs are given, then we do the routing, and after routing we'll do the redistribution. The redistribution is to share the information of one protocol to another, because each router protocol is working differently, so they cannot share the information from one to another. They can only be shared the information from one router to another, one protocol to another, is by with the help of redistribution. So the important point is that now we have to see that this is R1. So let's go on to R1 and we'll see. We are on R1. Okay. Now, so first we use the command show IP interface brief. IPs are there. Interface brief. So next command is we'll check if protocols are given. So protocols are not allotted. So we'll enable the protocols. Okay. On T. So first on R1 we have to give the OSP. On R1 we have to give the OSP. On R1 we have to give the OSPF. So the command is router OSPF 1. Okay. Network is, we'll give the default network, means 0.0.0.0 and any network and any wildcard mask. And area is, now this R1 is configured in area 0. So all the interfaces of R1 are in area 0. How we can check? Show IP OSPF interfaces. Okay. So we are having the interfaces here as loopback 1, 2, 3, fast Ethernet 1/0 and fast Ethernet 0/3. Loopback 1, 2 and 3, fast Ethernet 0/0 and fast Ethernet 1/0. Clear? Now we'll go on to now on R1. Now we go on to party. Okay. First we'll see copy to show IP brief or text only. We just enable the protocols while we are checking. Okay. Now router OSPF 2. Okay. Network is 12.1.1.0 and wildcard mask is 0.0.0.55 and area it's it will form the neighborship. Okay. Neighborship is formed. Okay. Now on R3 we'll go on to R3. On R3 first router OSPF 3. Network is on R1 and R3 we are having network 13. So 13.1.1.0 and wildcard mask is 0.0.55. Area is 3. Okay. Now on this interface OSPF is being enabled. You'll get the message on. Okay. On R2, R3, R1, R2, R3, OSPF is being enabled. Now we'll go on to R2 again. On R2, what we'll do, we'll enable EIGRP on interface S3/0 and F1. Or we can enable on 3. First is router EIGRP, let it be AS100. Okay. Now the network is 25.1.1.0 0.0.0.255. Okay. Next is network is 24.1.1.0 is the network. Okay. Now on R2 EIGRP is enabled. Now we come to R3. On R3 first enable the EIGRP in F0/0 and S3/0. Router EIGRP 100. Network is 34.1.1.0 and 0.0.0.255. Next is 36.1.1.0. Network is okay. Now on R4 we'll go on to R4 and we enable the EIGRP router EIGRP, that is 100, and network command is 0.0.0.0 0.0.0.0. Because on R4 all the interfaces are in EIGRP, so we enable the network command with 00, any network and any wildcard. Okay, and the area is 0, or area is not covered here. Okay, so all the interfaces are in. Now in EIGRP domain, I will go on to R5 on the router. So EIGRP and 100. Network is on this side. We are having 25 network between R2 and R5. 25 network is there. So network is 25.1.1.0 and 0.0.0.55. Next is 45 network. Now we go on to R6. See? Router EIGRP and it is 100. Network is on R6. What are the networks? The network is 46 network, and between R3 and R6 it is 36 network. The network first is 1.0 and 0.0.0.55, and next is 36 network. 36. Okay. Membership is up between all the routers till now. On R5 we enable the R5. Now on R5 RIP is enabled. Here OSPF is enabled, EIGRP is enabled, and RIP is enabled. So RIP is in version 2. Command is first is router RIP, okay, and version is 2, okay. And no summary. Work is 57.1.1.0. Clear? Now on R5 it is complete. On R6 will go on P, router RIP, version 2, no auto summary, and network command is 67.1.1.0. Where for R7 the command is router RIP, version is 2, no auto summary, and network is both. We have to give both the networks. or we can use 00 also. Okay, so all the networks are being enabled in that ref. Okay. Now we'll go on to R5 first and see IP route on. We are having the 70s network. Yes, we are having the 70 network with the help of RIP. On R5 we are having the 70s network with the help of RIP. That is the routing protocol. Now all the routing is being enabled. Okay, so now what we have to do, we have to redistribute. Where we have to redistribute? This is OSPF area 0 and this is EIGRP. We have to redistribute onto R2. Okay, we'll go on to R2. Okay. Yeah. Now the command is router. Now what we have to do, we have to redistribute redistribute OSPF into EIGRP. Redistribute OSPF into EIGRP. Now all the routes of the OSPF will be there into the EIGRP domain. On R2 first we'll go on to the router EIGRP, that is 100, and the next command is redistribute. Redistribute OSPF. Okay, now redistribute OSPF. OSPF is 2, metric is so bandwidth is, let's suppose we'll give the bandwidth as 1000. Now because this is EIGRP, in EIGRP we have to enable all the metrics because OSPF is using bandwidth only and EIGRP is using key values for the metric. Okay, so for the metric all the key values are to be shared. So we have to give that what will be the value of the metric we are using. So metric is for bandwidth, we have taken the metric. Next, bandwidth delay. Delay is, what is the delay? Delay, let's take delay as 100. Next is reliability. So reliability is means if reliability is 255, it is 100% reliable. Okay, I will take 255, and the next is next is load. So load will take as 1, least load. Next is the MTO. MTO will take as. So we have to remember this. We'll see this. This is being redistributed from. Now this is the command. Now from on in EIGRP we have redistributed OSPF. Now in EIGRP domain, this domain we will get OSPF network. So we'll check on to R4. Okay, first we'll go on to R4 and see the command show IP route. When we on R4, when we are using show IP route command, it will give us this 10 loopback, that is 10.1.1.0, 2.0 and 3. 10.1.1.1, 2.1 and 3.1. These are the IP addresses. These are being shared from in EIGRP from OSP. So EIGRP we can say D is for EIGRP and EX for external. So we'll get this route 10 networks route 10.1, 2 and 3 from EIGRP external domain, because we are in these on R4 we are having EIGRP. Yes. Now we'll check this. Okay. Now 10 network we are getting from the. Now this 10 network is on R4. This 10 network we are getting from R2. How it is? It is 24.1.1. Which is 24.1.1.2. R2 and R2. We are having a network that is 24.1.1.0. Is the network. This IP. I have taken the IP address like this. Between R1 and R2 the network is 12. Between R2 and R5 the network is 25. Between R2 and R4 the network is 24. Between R4 and R5 the network is 45. So I have taken lower value first. Means if it is Between R4 and R5, the IP addresses or the network is 45. Between R4 and R6, the network is 46, not 64. Okay. Similarly, in R4, we are getting the 10 network via R2. Because this is 24.1.1.2. No. This is no. Now on R5 we are getting this 10 network show IP route. We'll check on the R5. We are getting the 10 network. We are getting the 10 network from 45.1.1.4. On R5 we are getting the 10 network via 45. Why? Because in R2 and R5 we are having a serial. Serial link is having lower bandwidth compared to the fast Ethernet link. So we are getting the best route from R4 instead of. Okay, clear? So that is why on R5 the 10 network will come via R1 to R2, R2 to R4, R4 to R1 to R2, R2 to R4, R4 to R5. Okay? No. On R5 we are getting, no, R7 we are not getting the 10 link. Show IP. We are not getting the 10 link because redistribution is not performed between EIGRP and RIP. So we will perform the redistribution on R5. We will perform the redistribution on R5. So we go on to R5 and so EIGRP is redistributed in RIP. So we have to redistribute EIGRP into RIP so that RIP can get all the routes of EIGRP. So what is the command? Router EIGRP and 100. So router RIP. Router RIP. Okay. Next, redistribute EIGRP 100. Metric is hop count in RIP. So we'll take the hop count as let's suppose we'll take hop count as 2. No problem. Okay. Now you have to use the exit. Now we go on to R7 and we'll see if we are getting the results. Show IP route. Okay. We are getting the N network. We are getting the N network. Okay. Now this 10 network is first shared onto R2. On R2 we have done the redistribution. So this 10 network is there in the EIGRP domain. Next we have done the redistribution in R5. Now this redistribution. So we have done the redistribution between not between the protocols but one protocol to another. So OSPF is redistributed in EIGRP. EIGRP is distributed into RIP. So on R7 we are getting the 10 network. 10 network via on R7 we are getting the 10 network via R5. That is 57.1.1.5. This is 57.1. This interface R5 have 0 by 0 interface is 57.1.1.5. Now we are getting the. Now what we have to do in this scenario? Now so now on R6 we are getting the 10 network. Okay. On R6 we use the command do show IP route. We are getting the 10 network via 7. We are getting the 10 network via R7. Okay. Now what we are doing here is that this network is there on R1. So we have sent so this network R1 will be shared to R2, okay, because we have enabled OSPF between R1 and R2. Now on R1 we have done the redistribution. So R2, from R2 OSPF domain, this data is being shared to in EIGRP domain, because in EIGRP we have redistributed that. In EIGRP we have redistributed that this data is being OSPF is being redistributed into EIGRP. Now this 10 network is there in this domain R2, R3, R4, R5 is in this EIGRP domain. Now this data is being shared into RIP. If on R5 we do the redistribution in RIP for EIGRP. Now we have done the redistribution here. So on R5 this data is being shared onto R7. In OSPF the AS is AS110. OSPF AS AD is 110, and in R2 in this domain EIGRP is 100. The AD is 90 internal, but for external domain it is 170. Okay. Now you can see that on R5 if I show you on R5, show you on R5 to show IP route. You can see that N network we are getting via 170. Okay, and on R2 first we'll check on R2. Okay, show IP route. 10 network is via on R2. The 10 network is via AD is 110. Okay, on R5 the 10 network is via AD 170, because EIGRP use AD for internal network it is 90 and for external network it is 170. RIP will use the AD value as 120. So if we go on to R7, we use the command show IP route. For 10 network it will use the AD value as 120. Similarly on R6, when we go on to R6, if we see that from where we get the route of 10 network, we are getting the route from R7 to R6. Okay. So R1 will share this data to R2, R2 will share it to R4, R4 to R5, R5 to R7 and R7 to R6. Now on R6 we are getting the 10 network via R7. Now on R4 if we redistribute here from RIP to EIGRP on R6, we'll redistribute from RIP to EIGRP in R6, then there can be a possibility of the loop. Why? Because this R2, R5, R6 and R3 are redistribution points. Okay, so if we are having multiple redistribution points means on the router on which we are doing the redistribution. On R2 we are doing the redistribution between OSPF and EIGRP. In R5 we are doing the redistribution between EIGRP and RIP, and R6 and R3 similarly. Okay, so these are redistribution points also. Now on these redistribution point, if there are multiple redistribution point, there can be an occurrence of loop. Now you can see on R6 if we do the redistribution. How we can do the redistribution? First, RIP is being redistributed into EIGRP. So we use router EIGRP 100 redistribute RIP. Okay. Now, redistributed width metric is for EIGRP. Now we have to take the metric. Like if we take the metric more than the metric we have given on R2. On R2, we have given the metric. We have at that time I'll tell you that you have to see that which metric we have to take. Now, redistribute OSPF2 metric is 1000 for bandwidth. So this is the metric. Now we have to increase the metric. Means the 10 network is coming from on R1. On R1 it is coming to R2. On R2 it is coming to, from R2 it is going to R5. The 10 network from R5 the 10 network is going to R7. On R7 it is going to R6. On R6 this 10 network we are sending back to R4. R6 this 10 network we are sending back to R4 if we redistribute here towards R3, R4 also. Okay. Now this 10 network if we redistribute here, R4 is getting the 10 network from, if we see show IP routes. On R4 we are on R4. Okay. And we are getting the 10 network from R2. We are getting the 10 network from R2 because here the metric is from OSPF to, when we are getting in EIGRP, the metric of EIGRP is having bandwidth of 1000. I'll show you. The bandwidth is of 1000. If we increase the bandwidth here on R6, it will take this. It will take the best path from R6. Okay, it will take the best path from R6 if we increase the bandwidth here. I'll show you why. Now we'll go into R6. So the metric is 10,000. Okay. Now rest will take the same. We'll go into R6 and now redistribute it. Now we'll go into R4 and we'll see show IP router. We can see that for the 10 network, the best path is from 46.6. On R4, the 10 network is best path is from 46.6. Okay. So what is the concern here? So here we are having loops. Why? I'll show you. Okay. Now you can see now you can see on R1 this 10 network is going to via R2. R2 it is going via to R5, R5 to R7 and R7 to R6. Okay. Now on R6, okay, if we redistribute it here from RIP to EIGRP. Now here the metric is, let's suppose the metric is X. Okay. Here the metric is X plus 1. Means metric is, here the metric is lower, or we can say it is less than X. Okay. So if metric is lower, it is more preferable. Okay. Because EIGRP on R2 is sending the 10 network information towards R4 in EIGRP domain. R6 is sending the 10 network information towards R4 in EIGRP domain. So the AD value is same. So how the router will prefer the route criteria? The preference of the route is, first is the longest prefix, second is the least AD value, and third is the least metric. So here we are having the same network, 24 network, 10.0, 1.1.0 or 24 network. So the network we are having the same, means the prefix length is same towards R2. Now prefix length is same. So the second is AD value. AD value, we are in the EIGRP domain. So the AD value is also same. It is 170. Now the criteria will depend upon the metric. So here the metric is, means we are using bandwidth, that is 1000. Here we are using bandwidth as 10,000. So here the bandwidth is 1000 Mbps, here 10,000 Mbps. from where it prefer? It prefer from where the bandwidth is high. So R4 will prefer to go to 10 network via R6, not via R2. So what will happen if from R7 we are going to ping on R1, it will form a loop. Why? Because on R7 the best path to reach 10 network is via R5, it will go to R5. On R5 the best path is via R4, it will go to R4. On R4 the best path is R6, so it will go into R6. On R6 the best path is R7, so it will go into R7. Similarly, it will be in this loop. I will show you. We will go into R7 and we go into R7, and if we use that command trace route 10.1.1.1, so the trace route will form a will go to up to 30 hops. Okay. Now you can see if on R7, if I use the command trace route to reach 10 network. Okay. So 10 network is this. First it will go to the 57.1.1.5. On R7 the request will go to R5, because from R7 the best path to reach 10 network is R5. On R5 the best path is R4. On R5 the best path is via R4. On R4 the best path is via R6, that is 46.1.1.6. On R4 the best path is on R6. On R6 the best path is R7. So you can see it will create a loop 57.5, 45.4, 46.6, 67.5. Similarly again 57.5, 45.4, 46.6 and 67.7. So we can see it will form a loop. Okay. This will form a loop, and from TTL 255 it will go till round TTL 0. After TTL 0 this packet will be dropped, but it forms a loop. So the loop occurs in the redistribution points where we are having multiple redistribution points. Because in single redistribution point there is not a problem, because in a network where we are having multiple redistribution point there can be a problem. So it is mandatory to check the network thoroughly again and again to find that there must be no loop in the network. Okay. Thank you.